Hi everyone, myself Dr. E. Sridevi, Professor, Department of Biomedical Engineering, and in this video lecture we are going to learn about time response analysis of first order system. So time domain specifications and time response analysis of first order system. To understand the concept of time domain response, we have to know the basis of a closed loop system. So a closed loop system is the one in which the output or response is fed as the input of the system. Let R of S is the input given and C of S is the output. Some portion of the output is taken and which is noted as H of S, and it is fed as the input of this system. So this is the input, and R of S and H of S both are again given as the input, and which is noted as G of S. So G of S may be addition or subtraction of R of S and H of S. So here it can be written as R of S, and basis of this G of S and H of S which is connected in feedback can be written as M of S, and output is C of S. This M of S is the feedback system. Feedback system is noted as G divided by 1 plus GH. That is in case of time response analysis, G of S divided by 1 plus G of S into H of S. Based upon this, we are having the signals category. The signals, test signals are classified into three important basic types, and with that three we are having a step signal, ramp signal, parabolic signal, impulse signals, and sinusoidal signal. So from the step signals we are having unit step signal. From ramp we do have unit ramp, and similarly parabolic signal we have unit parabolic signal. So this all are called as test signals. So next is the step signal. Step signal is the one in which the mathematical representation is noted as R of t is equal to 1 when t greater than or equal to 0 and 0 when t less than 0. So the step signal is a signal whose value changes from 0 to A at t equal to 0 and remains the constant at A for t greater than 0. This step signal resembles an actual steady input to a system. A special case of step signal is the unit step signals, in which the amplitude of the signal is 1. That is why it is called as unit step signal. Then next is the ramp signal. So ramp signal is the signal whose values increases linearly with respect to time. From the initial value of 0 at t equal to 0, the ramp signal resembles a constant velocity into input to the system. So a special case of ramp signal is the which is denoted as R of t equal to A into t when t greater than or equal to 0 and 0 when t less than 0. So next is the parabolic signal. In a parabolic signal, the instantaneous value varies as the square of the time from the initial value of 0 at t equal to 0. This sketch of this diagram, which represents it is with respect to the time resembles to parabola. So parabolic signal resembles a constant acceleration input to the system. A special case of parabolic signal is the unit parabolic system, which is denoted as R of t is equal to A into t square by 2 when t greater than or equal to 0 and 0 when t less than 0. Next is the impulse signal. So impulse signal is the one in which large magnitude which is available for a short duration is called as impulse signal. The ideal impulse signal is a signal with infinite magnitude and zero duration but with an area of A. So del of t equal to infinity. This is it. This tabular column which represents the relationship between step, unit step, ramp, unit ramp, parabolic unit ramp, and impulse response, which is represented in time domain and its transform. For A it is A by S, and for 1 it is 1 by S for each step signal, and for ramp signal AT and it is A by S square, and T the that is 1 by s square. For parabolic signal, a t square by 2, that is a by s cube. 1 t square by 2, that is 1 by s cube. For delta t, the Laplace transform is 1. And the type and order of the system. So type is called as the control system, which is defined as the number of poles at the origin. At s is equal to 0 in the open loop transfer function. It indicates the system's ability to reduce steady state error. Then order of the system. Order of the system, which is called as the highest power of s in the denominator of the system transfer function. It represents the number of energy storage elements. So type and order of the systems are very important to determine the system behavior. So this section completely explain the time domain response analysis of the system with different signals: ramp, step, impulse and parabolic signals. Hope you all understand this. Thank you.